So we are discussing the section cylindrical capacitor. What do you know about the cylindrical capacitor? What is the capacitance of a cylindrical capacitance? Okay, so obtain capacitance of a cylindrical capacitor. Okay, shall we do it? So cylindrical capacitor consists of two coaxial metal cylinders. So you can find two metal cylinders. So axis same for both. So two coaxial metal cylinders are there. The radius of the inner cylinder is A. The radius of the outer cylinder is B. No doubt. So cylindrical capacitor consists of two coaxial metal cylinders. The radius of the inner cylinder is A. Radius of the outer is B. Then length of the cylinder is L. Then keep in mind L is very large compared to A and B. Okay. Then the inner surface of the outer cylinder is given positive charge. So by induction the outer surface of the inner cylinder will get negative. So from positive to negative there exists an electric field. No doubt. Then we want to find what is the capacitance of this setup. Capacitance is equal to Q by V. Then you calculate V, substitute here, you will get the capacitance. So for that we are doing, see, what is the equation to calculate potential difference? Potential difference between the two cylinders I want. So how will you calculate the potential difference? Tell me. Potential difference is negative line integral of electric field. You know the equation. So V equal to negative integral E dot dr. Then while deriving this, so we were moving a positive charge in the opposite direction of electric field. So E is like this. The charge is moved in the opposite direction. So what is the angle between E and dr? It is 180. So V is equal to, tell me, minus integral E dr cos 180. What is cos 180? Cos 180 is negative 1. So negative becomes positive. So what is your answer? V equal to integral E dr. Then here we are moving from inner to outer. Am I right? So what are the limits? A to B. A to B. No doubt. Then you put for E. You put for E. E means the electric field between the two cylinders. So I want the electric field between the cylinders. For that I consider a point P here. Then I am considering a Gaussian surface. It is a cylinder. It is a cylinder of length L and radius R. It is a radius is R. Then at P I am considering an area vector perpendicular to that in this direction or in this direction. Shall I consider this direction? So this is direction of electric field. This is the direction of area vector. So angle between E and dr 0. So what is the flux through this Gaussian surface? What is the flux through the Gaussian surface? Flux is equal to, tell me, flux is equal to closed integral E dot dr. E dot dr. Sorry, E dot ds. Then angle between E and ds 0. So this becomes EDS. Then E taken out. Then integral ds. No doubt. Then flux is equal to E as such. On integrating this small area, you will get the curved surface area. What is a curved surface area? Curved surface area is 2 pi RL. So 2 pi RL. Then we are not at all bothered about the end phases because the angle between electric field and area vector will be 90. So no flux there. Okay. So flux by Gauss theorem, flux is equal to 1 by epsilon 0 into Q. Am I right? So here you are getting two answers. LHS same, RHS equated. Tell me, E into 2 pi RL is equal to Q by epsilon 0. Then 2 pi RL put down. So E is equal to, tell me, Q by 2 pi RL epsilon 0. Q by L can be written as lambda also. So the equation can be written as lambda by 2 pi R epsilon 0. Otherwise you think as Q by 2 pi RL epsilon 0. Both right. So Q by L can be written as what? Lambda. So in that sense lambda by 2 pi r epsilon 0 is another equation. So I got the value of electric field between the two cylinders. What is answer? Q by 2 pi r epsilon 0 or lambda by 2 pi r epsilon 0. So I am putting here. So what is the answer of V? V equal to integral A to B. Tell me the answer of E is equal to Q divided by, tell me, 2 pi RL epsilon 0. Am I right? Then dr. Then V is equal to constants taken out. Tell me, Q by 2 pi L epsilon 0 taken out. Integral A to B 1 by R dr. Then integral 1 by x dx is what? Log x to the base e, or we write it ln x. Am I right? So I am putting it here. So V equal to, tell me, Q by 2 pi L epsilon 0. What is answer of this? It is ln R. You put this in a square bracket, A to B, no doubt. Then V equal to Q by 2 pi L epsilon 0 into ln upper limit minus lower limit, ln B minus ln A. Then ln means log to the base e. So log A minus log B, what is answer? Log A minus log B is equal to what? Log A by B. Similarly, what is the answer of this? Ln B minus ln A, it becomes ln B by A, no doubt. So V equal to, tell me, V equal to Q by 2 pi L epsilon 0, 2 pi L epsilon 0. What is answer of this? ln B by A. So we have the potential difference between the two cylinders. Am I right? So substitute here. So what is a capacitance? Capacitance is equal to Q divided by V. Q divided by that answer. So Q into, tell me, 2 pi L epsilon 0 ln divided by ln B by A. So you are getting your result. Then one Q is also there. Am I right? Q cancelled. So what is a capacitance? Q cancelled. So you are getting capacitance is equal to 2 pi L epsilon 0 divided by ln B by A. Is it clear? So once again I will explain. So listen fast. See, what do you know about cylindrical capacitor? Cylindrical capacitor consists of two coaxial metal cylinders. The radius of the inner one is A, outer cylinder is B. The length of the cylinder is L. L is very, very large compared to A and B. Why we are considering like that? Then only we can consider both these as linear charge densities. Am I right? Linear charge distributions. Now listen. See, this is the inner one, that is the outer one. Then I want the capacitance. What is the equation to calculate capacitance? Q by V. I want the answer of V. What is the equation to calculate V? V means PD between the two cylinders. So PD means negative line integral of electric field. Okay, we are moving from inner to outer. So limit A to B. Then electric field like this, moving outwards. So angle between E and dr 180. So E dot dr becomes E dr cos 180. That is E dr into minus 1. So minus E dr, that minus becomes plus. So we are getting this. Then you calculate for E and put here. What is the electric field between the two cylinders? Two cylinders, I want the electric field between them. How can I calculate? So for that we use which theorem? Gauss theorem. So we consider a point P here, including P, consider a Gaussian surface. It is a cylinder of radius R, length L. Then here you consider an area. Area vector is like this. Electric field is like this. Angle between E and ds 0. So flux is equal to, what is the flux through the Gaussian surface? Flux, there is flux only at the curved surface. No flux at the end face as angle between E and ds 90. So what is the flux here? Flux is equal to closed integral E dot ds. Angle between E and ds 0. So E dot ds becomes E ds. E taken out, then integral ds. On integrating ds, what can you get? Curved surface area. What is it? 2 pi RL. By Gauss theorem, flux is equal to 1 by epsilon 0 into Q. LHS same, RHS should be equal. So equating, calculating E. Then put it here. Then Q by 2 pi L epsilon 0 taken out, balance inside. Integral 1 by x dx is ln x. So similarly, integral 1 by r dr is ln r. Then for this r upper, then lower. Okay. Then log a minus log b form. What is answer? Log a by b. Here log b minus log a. So it should be log b by a. Then we got the value of v, put it here. So capacitance is equal to q divided by this answer. Then taking reciprocal, multiplying. So we are getting 2 pi l epsilon 0 divided by ln b by a. It is a capacitance of cylindrical capacitor. Okay, Abraham Shivan, got it?